following on from the previous video, we got to this stage here. We got to this stage here. So we worked out our unit tangent, and then to work out curvature, we need to differentiate the unit tangent with respect to time. So differentiating this thing here would then give us this thing here. So when you differentiate the unit tangent, it gives you this thing here. So now let me think. This is a constant, so we can actually take it out here. So so this thing times this thing, that will then give us this thing here. So so what's left is what's on the inside here, and we still need to work out the magnitude of this vector here. So using Pythagoras, square this, that will then give us this, and then square this, that will then give us this, square root the whole thing, that will then give us the magnitude. So the magnitude is really this whole thing here. This whole thing here is really, well, this thing here is going to be 1 square root of a squared, that will be a. So the curvature is given by this. Okay, so so now we need to work out the unit normal vector. So when it comes to unit normal vector, remember from your position vector, if you differentiate it, it will give you your velocity vector divided by its magnitude. Let's just imagine the magnitude is 3. When you divide it by 3, it will give you your unit tangent. And then remember, to work out the normal vector, the unit normal vector, you differentiate the t, the unit normal vector, with respect to time. That will then give you a new vector. And then this new vector here will be orthogonal to the unit tangent vector. Will be orthogonal. But then once you've got this new vector here, if you want it to have a length of 1, then divide it by its magnitude. That's why you divide it by its magnitude. Well, anyway, the unit normal is given by us differentiating the unit tangent vector. So so our unit tangent vector is this thing here. If we differentiate it, that will then give us this thing here. So similar to what we did in the previous video. If you differentiate it, that will then give us this thing here. So so this thing here is given by this. So now we need to divide it by its magnitude. So we've got this thing here at the moment. Let's work out the magnitude. So the magnitude of this thing here will be us using Pythagoras on this. And remember, this is just a constant. If let's say, let's just imagine if you've got a 3 here, 3, and then you've got well, you've got this vector here. Let's just imagine that the point I'm trying to make here is that if you want to work out the magnitude of this, you can just concentrate on finding the magnitude of this, because this is just a constant. So finding out the magnitude of this would be this squared, and then this squared, and then take the square root of the whole thing. That will then give you this, and then just multiply it with this constant. The reason why you're able to do that is because well, let's just look at this bit here. You've got a vector here. Let's just imagine this vector here is something like this, and then let's just imagine this is a constant. So let's just imagine it's 3 lots pound. Let's say this vector here is given by this, and then you've got a constant here. So it's going to be 3 lots. Let's just imagine it's 3. So to find the magnitude of the whole lot here, you can just concentrate on finding out the magnitude of this, which is what we did here. And then once you've got the magnitude, multiply it by 3. 1, 2, 3, and then it will have the same effect. So so work out the magnitude of this. That will then be this. Tidy this up. That will then give you this thing here. And then to find the unit normal, get our vector, divide it by its magnitude. So remember, hang on, this thing here is this thing here, and then we need to divide it by this thing here. So don't forget, this is just a constant. So we've got our vector here, which is this thing here, and then we need to divide it by this, which is us multiplying by the reciprocal of this thing here, which is this thing here. So our unit normal vector is given by this whole thing here. So now these two will cancel each other out, giving us this thing here, and then you've got a constant here, factor it out, cancels out. That will then give you this. So a unit normal vector is given by this. What that means is, for the helix, as the particle is moving along here, the normal vector, well, there's no k components, so there's no vertical movement. As the particle is moving along here like this, the normal vector will always be parallel to the x y plane. It's always pointing towards the z-axis. So as the particle is moving, the normal vector is always pointing inwards like this. It's always pointing inwards like this. It's always horizontal. It's always because there's no vertical component, so it's always pointing inwards like this. Okay, and it's always horizontal. Okay, so this is your final answer here.